22 is kind of a clever way to incorporate all kinds of geometry and probability all in one problem. First of all, it says if 3 triangles are chosen at random without replacement, what is the probability that the first 2 triangles are right triangles and the last triangle is obtuse? So I'm thinking that the first thing that we need to do is identify which triangles are right triangles. So I'm going to call this one a right triangle, rather obvious because it has a 90-degree angle. This is a right triangle. By the way, this is an equilateral triangle. Do you see those 60-degree angles? This is clearly an obtuse triangle because it has a 140-degree angle in it. And this one is going to be, well, acute because all the angles are acute. So what is the probability that the first 2 triangles are right triangles and the last triangle is obtuse? So let's find, obviously our denominator is 5 and we have 2 right triangles. So there's 2/5 and then times no replacement, right? So that leaves us with 4 triangles to choose from, and we've already taken one of our right triangles out, so now we're left with 1 triangle, 1 more right triangle, and then the last triangle is obtuse. Well, obviously we've already used up 2 of our triangles, so that leaves us with 3 to choose from, and then we only have 1 obtuse triangle in the mix, so that's where we get our 3 probabilities. We multiply 2 as the numerator, and then the denominator is going to be 60. So that reduces to 1/30. So that's our probability for A. And then for B, if 3 triangles are chosen at random without replacement, what is the probability that all 3 triangles are right triangles? People, there aren't even 3 right triangles. So here's the deal. The probability is it's not going to happen. 0. All right, letter C, if 3 triangles are chosen at random without replacement again, what is the probability that all 3 are isosceles triangles? Okay, well, to talk about isosceles triangles, remember we have to have 2 of the sides have to be the same. So for the 45, 45, 90, right, that is an isosceles triangle, okay? The 60, 60, 60, the equilateral triangle is actually also isosceles because all that, in order to be isosceles, all it has to have is 2 congruent sides. So certainly that will work. And then the last one is going to be this one here. This one is also isosceles because it has 2 angles congruent, which means that the sides opposite those 2 angles are congruent. So we have 3 isosceles triangles. So it says if 3 triangles are chosen at random without replacement, what is the probability that all 3 are isosceles triangles? Well, obviously we have 5 to choose from here, and then there's 3/5. So favorable over total. But now our favorable is only 2 because we've used up one of them, and then the last one is going to be 1/3. Can you see that we've all of these numbers are dropping here? So we have 6 over 60, which gives us 1/10. I hope that makes sense to all of you. Excellent review of some geometry skills that I hope you have not forgotten.